Welcome to another episode and video on my robotic arm with pneumatic hand, arm pivot, controller, which is a robo interface with extension, compressor, lower gearbox, and counterweight to keep balance with the arms, with the hand. Last time I added this construction and that turned out to be necessary since with the counterweights spread over the arm, the cord connected to the lower gear, the thin blue line you see there connected to the lower gear here, was so much imbalance that the pulling effect of the lower gearbox was no longer effective at all. It was really imbalanced and I can't use that. However, in the current situation, the box is only connected here and on the other side, which is not really nice. I have to connect them here as well, so that's what I'm going to do. Now the thing is though, that you may notice that this is a little bit different now. It is really constructed in parallel now, and I did that after finishing the recording of last episode. Reason is that this is more robust and better to be handled, better for the material as well. So in this situation, let me modify this construction by adding two of these, and this should be a nice fit. So now they're keeping themselves in balance. Or you should do anyway. So now if I do this, it's very lightweight. I don't have to put some real effort on it, and this should do it. What remains on this side is, well, of course I have to take care that the weights are really on this position and not somewhere here. Which brings me to the next point, which is the lower gearbox. Because in the algorithm it is supposed to be that continuously the lower gearbox should run back and forth between the upper and the lower gear sensor in such a way that the arm keeps moving like this, and that is not the case. If neither upper nor the lower gear sensor is being, or gear sensor, whatever, is being pressed, then it should run to the upper gear sensor, and then continue with the rest of the algorithm. but it doesn't happen. So I have to take a look at the algorithm of the lower gearbox and see how I can improve that. So let's take a look and see how that works out. Recap from last time. Using the diagnosis, I managed to make difference between the gears. So let me grab this one and make sure that it is indeed the right motor, which is 1. Yes. So in one direction I need 3 and in the other direction I need 2, and then I am talking about speeds. And here it already gives a problem. Alright, now it touches the switch, which is the lower switch. It goes up and does a very nice job. And here it doesn't. So, alright, and then 3, and then it does a job. 2, all the way up, and yes, when I do 2 here, it does it too. It's not consistent. And then with 2, then I'm talking about 2, and then it stops. So no matter what and how, it is far from consistent, and that is a problem. Why? I still haven't found out why it is so inconsistent. Anyway, let's take a look at the algorithm. So 9 is the lower and 10 is the higher. And then normally you say up and down, but let me change this to down and up, because that's more logical in the way that this is the lower gear, the lower sensor, and this is the upper sensor. Anyway, do it with 3. And a movement for 1 second. If not, then the movement for 1 second, again, again, and again. And this should work. And the best should be to test it using a separate algorithm. So copying this one, this part, and inserting this one only. But, well, let's just try it. And unfortunately I can't use an on-screen cam. The computer is not strong enough for that. So let's just, yeah, and that's already enough, because it should have started by now, as you can see in the algorithm, but the motor doesn't move. So let me wait until the pivot switch is flipped, which is now, and until the arm is back into its hope more or less neutral position, and none of the other switches are working. So what is happening is that the arm is not moving up and down, the wrist is not moving back and forward, which by the way may be due once again to the wiring, and that still after all the time is still a weak point in the setup. So I have to correct that later. Then with this comes the yaw motor with switch that doesn't work either, which is this one, and you see that it is not being pressed right here. It's not being pressed, although very close, but well, not is not. So while this should be working, it checks all the conditions, and here's one not condition. How can I change this that it just does its job? In this case, if not the digital 9, I can make it to go to digital 9. How easy can it be? Or not digital 10 and then go to digital 10. Right now it's going up to the right, which means, and right, I think that is going up, not quite sure though. This was going up, I think, yeah, that is right. So then it's going towards the upper switch. But how can I change this that it doesn't do it anyway? If I change the algorithm for now, alright, and see how this works out. Will I do it? No, it should have done it by now, straight away. And it says not digital 9, but the motor is not responding at all. So now if I take the diagnosis again, what happens? If something happens. Alright, slave again. I hear the whining of the motor. Alright, that's left and that is down. Alright, that works. So leaves the question, why does the motor, why don't I hear a whining motor when I run the algorithm? And that is the problem. If that isn't consistent, what is? I don't like that at all. Right, so now I've changed the algorithm a bit, and now focusing here, it's not touching it, and it is then the upper sensor. So point is now when I run the algorithm, it's going to turn, so we don't see it. But so be it. Let's see whatever happens for now. Running it. Alright, and you can see that nothing is happening. Nothing happens. This should be running around. So, interface, the diagnostics interface again. And I need to go down now. And that worked. Up. Yeah, and that's a problem. When I change speed back to 1, it stops. So 2 is not enough. Down. And this works. Alright, this doesn't work because I changed speed in the meantime. Consistent 2. No, that's not consistent. And see, here I have a problem. The motor doesn't go until I set it to full speed. Yep, and that is too fast. That is way too fast. So why does it do that? Consistent speed 2 works. Consistent speed 3 doesn't work. Back to 2. Yeah, and I change speed, so I should lose it. Or this doesn't work. This does. 3 doesn't work. You hear the whining of the motor. It does want to do it, but it doesn't. Up. Works. This doesn't. And this, the new speed is 3, speed 3 down. So why doesn't it do that? You hear the interruptions in the winding of the motor. And that is me changing the speed in the diagnostics interface. Currently 4 down, 5 down, 6 down, 7 down, and that goes like crazy. 2 up. Also not a fluent speed, but it does its job. Stop. 3 down. Not working. Stop. 2 up. Works. Alright. Full stop. 3 down. No go. Now 3 down. Doesn't work. So if the diagnostics interface even doesn't do its job, how can the algorithm do it? Maybe, just maybe, I should change the motors. See whatever happens. Going to be a hell of a job because I would have to change to tear it all apart and change the motor, but I could also just make some mock-ups. Just put 2 motors with a gearbox on it and see how they respond. And that on both sides. So let's set that up and see how the motors respond. I'm very curious about that one, because this certainly isn't going to work for whatever reason. Now I've put identical motors here and here. So let's do a short test to see how this goes. First of all, once again with the diagnostics. This is not running fluent. That one is. This one is not fluent. And I can easily hold it down. There's not much, there's hardly any force necessary to slow it down. And that's worrying. So let's do it the other way. Speed 3. How about this one? This one is a lot stronger. But this one I can slow down without a problem. This one doesn't allow me to slow it down. This one clearly does. Right. Back to the other direction, speed 2. I merely hold my finger on it and it slows down. And this I just hold my finger and it stops. It wants to go on, but it has the force to go on. And this one just goes on without any problem. Doesn't let me stop it. So, and I hear the rhythm of the motor going on. So if I take this one off, I hear that motor go. Now what happens? Oh, I don't like that one. Seems like this motor isn't correct. What if I take this one out? Oh, absolutely nothing. So this is a bad motor anyway. Yeah. Not promising. Alright, so much for this test. Brings back the question how to solve this, because in the past this certainly did work. And then I don't mean this, I mean the vertical gearbox. It did work. So what has changed? And to be honest, I don't know. The algorithm has been like this for quite a while. So what's the culprit? I don't know. So the problem now is that diagnostic interface shows inconsistent behavior of the motors. The replacement motors, well, one of the replacement motors doesn't work very well. The other has no problem. So now is the question, do I use faulty motors? On the other hand, this is still not what I like. This is better, but it doesn't do it the way it should. Does it need modification? I really don't know actually. I think it is necessary to keep them here, because if you go somewhere in the algorithm and you test conditions if this or if that, and it is neither, you have to have a condition that catches that, and that should be this one. You can work with a status, like if the state is digital 9 has been touched, then do this and then change the status. Could be. On the other hand, it's not necessary if you say just if it's in between 9 and 10, just do something. And if you look here, it is all the way neither. So not digital 9 and 10, and also not digital 11. Well, 11 is quite logical because it's not moving, and most likely because one of the wires is not activated right now. I still have to reconnect, so that's logical explanation. But this condition is clearly met, because otherwise this wouldn't be printed on screen. So why doesn't the motor work? That's the big question. What if I change it to left? That's another one. Let's test this shortly. So if that is the culprit, oh yeah, right, I have to disable the interface first. Close. Go. Oh, that's remarkable. It did it and then immediately shut down. Once again. No, stops. Okay, that is weird. It did for one moment exactly what it had to do. Go left. And then stopped, and the second time I started the interface it didn't do it. One more time. And what's happening? Yeah, it flips the bipolar switch of the arm. Goes back. But that's all it does. So, stopping the algorithm and changing this back to right. What happens? It works. It worked. But then it says print direction is links, which means it is here, and it doesn't do a thing. It just stops there. So is the sensor still printed? Is it still there? Alright, let's stop this for a moment. So it keeps printing. It keeps printing. And that is, well, not digital 9. But it doesn't say that 10 is being printed. And that's the point. If the digital, this is not being printed. So I should extend. Let's see. Is this algorithm correct? That's a very good question, and I doubt that right now. But I noticed that time is up, so this investigation on these conditions has to go to next time. I suspect that here's a problem. Yes, time to wrap up this episode. So, the motors are not functioning correctly, and in the very last moment they do something, but where the if not and if not for 9 and 10 are is suddenly being carried out correctly, it stays up. It doesn't go down anymore. Then I need a condition to be sure that this sensor is still being touched, and the algorithm doesn't do that yet. That is for next time. So for now, thank you for watching. If you like this video, please subscribe to my channel if you haven't done so yet. Give the video a thumbs up. Leave a comment, very much appreciated. You can also follow me on Twitter. If so, retweet and like. Leave a comment. You can also follow me on Instagram. Please like and leave a comment. Please donate to keep videos coming to you. You can also become a patron and have your name mentioned. And this is going to be continued with once more a focus on the lower gearbox with hopefully an improved algorithm. Once again, thank you for watching.